We are moving on to 2.5, learning target. You can solve one-step equations through addition and subtraction, all involving integers. So, the main idea in these next two lessons are solving equations. When you say solve, you need to know that solving is getting a variable by itself. Solving means figuring it out, finding an unknown. In order to solve an algebra, we need to apply inverse operation. An inverse operation is it undoes an operation. It flips it. It cancels it out. In solving equations, all solving equations means is getting the variable all by itself. That variable is, there's no negative attached to it, there's no numbers near it, it's all by itself. So solving equations is getting variable alone. Algebra is all about inverse operations in balance because the main goal for algebra is to solve equations. When you solve, you want the variable by itself. How you get the variable by itself is applying inverse operations. And then the main heart of it is you have to keep things balanced. You can't just change things around unless you do it to both sides. If you do things to both sides of an equal sign, you can do whatever you want to any expression. So balance means what you do to one side, you do to the other. What you do to one side, do to the other. That is the most important information for solving algebraic equations. Reiterating the fact that equations must be balanced, I have important info here blinking at you obnoxiously, telling you that equations must stay balanced, have to, or you are not solving correctly. If you only do something to one side, you have broken the rules of algebra. What you do to one side, you must do to the other side. To solve one-step equations, the first thing you do is determine what inverse operation you need to use. So I say, what am I doing? What's the opposite? That's asking myself what an inverse is. So to solve one-step equations, I determine what inverse operation I need to use. And so you need to know the inverse. Inverses are really, remember, you're undoing it. You're canceling it out. You're asking yourself, what's the opposite, is the big quote. Whoops. What's the opposite? So, if I had an operation sign of addition, what's its inverse?
Subtraction.
Subtraction. Subtraction undoes addition. If I had a subtraction, what's the inverse of subtraction?
Addition.
Add. Adding undoes subtraction. It cancels it out. Multiplication, what's the inverse to multiplication?
Division.
Division undoes multiplication. It cancels it out. Division, what's the inverse?
Multiplication.
Multiplication, I use an asterisk. You can use whatever you want. I wouldn't really use an X because now we're talking about algebra and variables are going to be present. So division, multiplication undoes division. Those are all the inverses, all the opposites. The most that you're going to deal with. Now we're going to get intense with them, but that's really the four operations you need to know. And you need to know how to distribute because we're going to solve multi-step. And you need to know how to combine like terms. Move it. Let's do some examples. So the stats laid out pretty explicitly here. Determine what inverse operation to use. And secondly, you're going to do the inverse operation on both sides. So first, determine which inverse operation to use. And secondly, do the inverse operation on both sides. That's the balance that I'm talking about. Algebra needs this balance. Now a lot of you can solve this mentally. I'm not asking if you can do this in your head. I'm prepping you up for multi-step equations and being a strong algebra student. So you need to show your work here, okay? And I'll decrease the amount I expect as we get further along. But here I need to show that I'm assessing you on inverse. Here I'm going x plus 4. What's the inverse of plus? Minus. So I'm showing that I need a minus 4. That's inverse operation. And now I'm showing that I'm balancing. I'm doing it to both sides. What really happens? This cancels out, and I get x is equal to 5. Beautiful. And yes, I could do that in my head, and I'm sure you could too, but that's not the point. X minus 3 equals 7. What's the inverse? Plus 3. So now I'm going to add 3 to both sides. I'm staying balanced. Both sides of the equal sign. I know that you used to learn, some teachers teach it like this. You have two sides. You add 3 to both sides of that line. But I'm not a big fan of that strategy, so I just ask you to think you have a left side of an equal sign and a right side of an equal. So if you're going to add 3, you do it to the left, you do it to the right. The negative 3 and positive 3 cancel out, and you get x equals 10. 5 plus x equals 7. So what's going on here? Yep. Minus 5. I'm asking myself, so I'm not really, I could rewrite this x plus 5 equals 7 and then realize what I'm doing. But I always think that inverse means opposite. So I say, okay, what do I need to move? I need to move this 5. What's the opposite of that 5? Positive or negative? Negative. So I know then that to undo it, I would subtract. Okay? X equals 2. Beautiful. All right. Continuing forward with one step, we just need to identify what would we do, which inverse operation would we do? X plus 7 equals 20. What would we do to move it? Just tell me out loud. I'm minus 7, yes. That's what I would do. And part of your homework, I think, says to identify which inverse operation you would use. And it would be minus 7 would be my inverse operation. X minus 4 equals negative 2. What's the inverse? Plus it is the inverse. All right, that was pretty decent. All right, the next ones are just examples. So I want you to take a moment, I have quite a few examples on this page, and try to apply the inverse operations. Compare with somebody next to you. We'll come together in 2 minutes. Looking at example A, x minus 5 equals 10. If I'm minusing 5, the inverse would be adding 5 to both sides. And I get x is equal to 15. Work is done. Y plus 9 is 15. The inverse of plus 9 is subtract 9. And I get y is equal to 6. M minus 8 equals 14. The inverse of minus is add. So I'm going to add 8, and I get m is equal to 22. 8 plus 8 is 10. The opposite of adding 8 is subtracting. So I'm going to do it to both sides, keeping the balance. I get 8 is equal to 2. I think we've had enough examples here. So I'm going to call it short and move to the next page. Oh, that's it for today's lesson, actually. For 2.5, that's it. So I might as well just go through and finish up these examples and for closure. X minus 2 equals negative 4. What's the opposite of minus 2, guys? plus 2 to both sides. Negative 4 plus 2 is a negative 2. Opposite of adding 9 would be subtracting 9. And you get x is equal to 6 minus 9 would be a negative 3. Or you could say 6 plus a negative 9. Both techniques work. Y plus 5 is negative 1. Opposite of plus would be subtract. Here I'm actually going to do something a little different because so many kids mess this up. I would write that as negative 1 plus a negative 5. They're the same sign, so add them up, keep it negative. It should be y equals negative 6. Subtract 11, negative 8 equals x. It doesn't matter if the variable's on the right-hand side, you still do the same thing. You just try to get the variable by itself. So, that's all for solving with adding and subtracting.